here. All right, so we covered method defaults up to this point, and method chaining. This is just something fun that you're going to be doing more and more of. Once you get better at programming, I'm noticing a ton of lines of code right now, and that's okay. But as you get more and more proficient, you're going to start chaining things and try to smash things together. And it's always fun to try to solve an algorithm in one line, just to kind of stretch yourself a little bit. But if you're not at that point, don't worry about that. It takes a long time. We're going to talk about object orientation at this particular point. This can be translated to other languages, maybe not directly, but the concepts will most likely directly translate. So we'll just do object orientation example. Inside of Ruby, Ruby is an object-oriented language, and every single thing is an object. So hashes are objects, strings are objects, booleans are objects, arrays are objects. And what that means is, even on a string like this, I can do stuff to it. I can shuffle the letters, or I can't shuffle the letters. I can uppercase all of the letters. I can lowercase all of these letters. I can call methods directly on any sort of data type inside of Ruby, because everything is seen as an object. So I can just do dot whatever to an object, whereas in other languages that may or may not be the case. So for certain things inside of JavaScript you can do dot, other things you cannot do dot on inside of that. So up to this point, we've just been writing pure methods. Like we said, like add to number. Like from before, we have num1, num2, and then we were just writing methods that did something. Just to be. And this is great, but it's not usually how people write code. So there's two paradigms of program. There's one of them is called functional programming, which we won't talk about a terribly large amount right now because we want to talk about object orientation. And the second one is called object orientation. Today we're going to start doing object orientation using repetitive code that we can repetitively use. So we're going to define everything in what's called a class. And classes are used to combine how data is represented, and also includes all of the methods used to manipulate that particular bit of data. So let's think about, you can think of a class as any sort of noun. So just call out a noun to me. A dog. I've used dog literally every single class. All right. There are a few things that every single dog has in terms of attributes and verbs that these dogs can do. So we're just going to start with the attributes.
Legs.
What's that?
Legs.
It does have legs, but generally speaking, how many legs does a dog have? Okay, so we have, let's just say we have legs. We're just going to say that to be 4 right now. These are comments. Remember, we're just going to write a few things. What are some other attributes of a dog? Things that you can give a dog, like let's pretend you're God for a second, and you can create dogs. Actually, no, that's pretty much just breeders. Let's pretend you're a dog breeder, and you can control different attributes of the dog. Like what are some attributes of every single dog? So one is legs, sure.
Disposition.
Disposition, sure. But I'm thinking even more basic. There's a breed. Thank you. Breed is an easy one.
Hair length.
Hair length, sure. Hair length. Name.
Age, maybe.
The age we can talk about, sure. Let me just get one more thing.
Tail.
Tail, like true or false, right?
Yeah.
All right. So when I create any dog, so the idea behind a class is that it's a noun. It's something that's reusable. I can create many different instances of this particular dog. So if I'm a dog breeder, let's say I breed golden retrievers for yuppies in downtown Chicago, right? So my clientele is rich young professionals who will come out and pay $10,000 for my genetically pure golden retriever dogs. Whenever I breed a new dog, there's certain expectations that I can give onto this dog. Things like I expect all my dogs to have 4 legs, expect them all to be golden retrievers, hair length, name, age, tail, all this type of stuff I can breed into my particular dog. But let's say like down the road, I also have like I move beyond golden retrievers and I can do Dobermans and Saint Bernards and things like that. I can pass all of those things into an initialize method. And the initialize method is basically saying whenever I create a new dog, I'm going to be passing it a few things. Let's just say breed, hair length, and name. Not to say that these other things weren't valuable, but just because there's too many of them, I'm just going to do 3 things. So I have a dog. It's like the class dog. Imagine you're creating a dog you're a dog factory. Okay. You can create many different dogs, and each individual dog will have its own breed, its own hair length, and its own name. Like so. I'm gonna be writing a little bit of code real fast. Let's call it a dog name. So the initialize method, it's also called a constructor inside of JavaScript, is to create this new dog. The parameters that you pass in are traits of the dog, things that you're going to be using later down the road inside of your code. Something that every single dog is going to have. You don't need to initialize with anything if you don't want to, but let's say for now that every single dog has a breed, a hair length, and a dog name. You may be wondering why there's like an @ symbol over here, and this is just Ruby syntax in general. This means that it's an instance variable. Instance variables, so the difference, remember, we had regular variables, def do something. We have any variable equals 1, 2, 3. Any variable is what's called a local variable. It lives within the context of this particular method. When I have a class and I have the @ symbol in the front, it becomes an instance variable, meaning that I can use @breed, @hair length, and @dog name inside of any one of these methods inside of here. So again, local variables, nothing in the front, only lives within the context of line 8 through 11 here. This @breed stands for an instance variable. It exists within the entire instance of this particular dog. Sean?
It's kind of like this, right?
It is this.
And is that for every, not just classes, but every object, can you have an instance variable?
Every single, so it's specific to that particular instance. It's not a class variable. It doesn't go to every single dog that you create.
So it's like instance variables and global variables. It's like global variable is like it applies to everything within your writing, and the instance variable is just whatever that particular class of dog.
Yep.
Just applies to just that, but it's movable within that dog. I'm not articulating this very well.
Sure. Let me explain it in one other way.
Okay.
So every single person here in this classroom is an instance of the class person. Like whether or not you believe there's a creator of all human beings, we are all human beings, right?
Okay.
And we each have certain things that we know about ourselves. We have a skin color, a hair color, a race or something like that, and a name. So when I call upon James, what is your name? There, within himself, he has an instance variable called name that he knows that he can give out to other people. I also have a name instance variable, which is John. I have a race instance variable, which is Asian. So it's kind of like you are all instances of people. There are all things that you know about yourself that you can rattle off really fast, but they're not shared between us. Like I'm not white, right? I don't have blonde hair. Sean?
I see how this works for your initialize.
Mm-hmm.
I get that. I get how you're using it. Say we had like some other object, and I've created. It's not a class object.
Sure.
Could I use the same thing to point to whatever is in the object itself the way you would in JS, or is it totally different?
It's not the same.
Okay.
It's not the same. I saw some other hands. Yeah.
So I noticed that all your I forgot the name. What's the instances are being defined as arguments and initialize.
Mm-hmm.
So if you wanted to have like a class with like 20 instances, would you have to be passing 20 arguments to an initializer?
Yes. Yes.
That's the
What
only way to
happens
do
if
it.
you don't?
What's that?
What happens if you
So the question was like, we saw that a dog, whenever we want, so again, local variable, nothing in the front, only exists for this line 9, this any variable, exists only within the context of 8 through 11. It dies outside of there, right? It's kind of like a fish out of water. It just doesn't exist. But we have like, then we have this thing, this ampersand, this @ sign in the front. This makes it an instance variable. It exists within the context of this entire dog. So it lives between line 1 and line 12.
In the context of the object, is that the right thing?
In the context of the instance of the object.
you provide defaults for everyone you make?
No.
You don't.
So you do not. So the question that John had was, like right now, it's like I'm passing in just 3 things. If I were to pass in, if I needed to know 20 things, do I need to pass all 20 things in? And the answer is yes. And that's why I recommend, like generally speaking, just pass in the things that you absolutely need up front. So in the case, think of it like a bank account. So there's a lot of bank software and a lot of financial software, and you fill out a bunch of forms. You'll realize very soon that the web is just one giant form. Because everywhere you go, you log in, it's a form. You order something, it's a form. You enter your credit card information, it's a form. The entire web is one giant form. But they will just take what they need in order to create your particular instance. So it's kind of like when I sign up for Chase, whenever you fill out the application for a Chase checking account and stuff like that, they take all of that information in a particular order and just shove it inside of an object like this and then save that into a database. So it does need to be in the correct order. Right now, like just for simplicity's sake, I'm just having 3 things. Otherwise, I could have 20 if I wanted to, but I'm just having 3. All right. So you can think of instance variables in layman's terms as an adjective to a noun. Like this is a description, like this describes this particular dog. This dog has a breed, a hair length, and a dog name. I know it's attributes to it, but you can think of it as kind of like this. These are things that you can use to describe the dog, like attributes about itself. So let's create a new dog. So we'll call this my dog equals dog.new. So I'm going to create a new dog. It's going to, let's say we're going to make it a golden retriever. We're going to have, they have long hair. And the dog's name is Lucky, which was, all right. So I have this dog here. And this dog, I'm passing in, and it does have to be in order. It's going to be, the breed is going to be golden retriever. It's going to have a long hair length, and the dog's name is going to be Lucky. So when I run this particular bit of code, nothing happens. I created a new dog. I'm not telling it to do anything. If I told this dog to tell me its breed, its hair length, and its dog name, it doesn't actually do anything. So let's say breed, hair length, and dog name. The very beginning of here. Right now, everything blows up. So we read object orientation example, RB, so that on line 15, there's an undefined method called breed. So it breaks here. It doesn't even execute 16 and 17. It just stops at one particular point. So I've defined the instance variable up top, but I don't have a method outside of it to actually call that particular instance variable. So it's kind of like saying when you let's say you have a kid, when the kid is born, you give the kid, generally speaking, a name. So there's an instance variable that kid has called like Peter or something like that. But when you ask the kid for the name, there's a method that you need to write. Like they need to know that when somebody asks me, what is your name? Like that's a method that they have to know. Oh, there's an instance about myself. I know my parents keep calling me Peter. So whenever somebody asks me the question, what's your name? I have to respond with Peter. So right now, even though I know the object itself has this breed and this hair length and this dog name, it doesn't know how to respond to that. So I'm going to create a method called breed. It's just going to return @breed. remember, I didn't define it anywhere inside of line 8 and 10. I defined it within the initialize on the first particular line. Once I define it up here, it's available everywhere else within this particular instance. So let's see what happens. I've fixed line 19. Let's see if something returns out to me. All right, so you can kind of see, before I had nothing, now I have golden retriever coming up, and it breaks on line 20. There's an undefined method hair length. So now hair length is nothing. So again, it's like, this doesn't really work with dogs because you can't ask a dog how long is your hair, but just play along. So again, let me just do a quick review. We'll see this work, and then Sean, I'll get to your question. So a class is usually refers to like one particular noun. There are attributes, adjectives to this particular noun that you throw inside of the initialize. So every dog that you create as a breeder is going to have a breed, a hair length, and a dog name. So you give it those particular things, and inherent inside each individual object, they know its breed, its hair length, and its dog name through this @ sign at the beginning. It makes it an instance variable. It's available everywhere within this particular instance of dog. This instance variable is not to be confused with the local variable. On line 21, this any variable only lives within the context between lines 20 and 22. The @breed, the @hair length lives within lines 1 and 23, or as long as this class is going to go on. I can use it anywhere over here. So on line 25, I've created my dog. I've given it the breed of golden retriever, the hair length of long hair, and the dog name of Lucky. When I ask the dog to give me its breed, it goes inside of the dog class, finds the breed method, and you can kind of see it just returns @breed. And since I passed that in on line 1, it's going to give me golden retriever. Hair length is the same thing. This particular dog, my dog, is an instance of the dog class. When I call the method .hairLength, it returns the instance variable of hair length, which is going to be this long hair over here, and so on and so forth. Let me just see this work, and then Sean, I see your question. We'll get to that. So we have golden retriever, long hair, and Lucky. Sean.
Seems like having to create the methods, could take a while.
Yeah. That is exactly what I was going to get to next. Yep. So right now, you can kind of see that most likely, if I initialize a dog with any sort of attributes, I'm going to need to use those attributes over and over again. Yeah. And I've written 3 stupid methods. Like this just returns this. Hair length just returns hair length. Dog name just returns dog name. And Sean caught on to it. It was basically like, this is going to take a long time if we have 20 things in a row. So what we're going to do is we're going to create all of these into getters. So getters are basically, I'll just write it real quick. So attribute breeder, breed, hair length, and dog name. This line 2 stands for attribute reader. This is what's called a getter. A getter basically gets different attributes that you've assigned to this particular object. So it gets the breed, it gets the hair length, it gets the dog name, or in our case, it reads the breed, it reads the hair length, and reads the dog name. By adding this one particular line, I can actually get rid of all of this code and shorten it up. So again, my dog, it's just a noun, it's reusable code, because right now I only have my dog. Let's create somebody else's dog. Who actually has a dog here? I don't have a dog. All right, Tristan's dog. All right, so we're going to create a new dog. What breed of dog do you have?
Pound dog.
Pound dog. Okay. Is it a short hair, long hair? What's the short hair? And what's the dog's name?
Its name is Jack.
Jack. Okay. So this class is a reusable piece of code. I can create different instances of it. So I have my dog, which is a golden retriever with long hair named Lucky, and Tristan's dog, which is a pound dog, short hair, named Jack. When I initialize a new dog with these particular attributes, I set the instance variable, and once I set the reader available to it, I can use that anywhere. So I'm going to do everything with my dog, And I'm going to do everything with Tristan's dog. So you can kind of see I have that golden retriever, long hair, Lucky, and then I go into Tristan's dog, which is pound dog, short hair, and Jack. So I've just taken all the code that we had, which was like, I think 12 lines of extra code, and turned it into one by using attribute reader. This is the concept of a getter.
It doesn't matter that attribute reader is in the class before initialize.
It's supposed to be in the class before the initialize. That's just like the location of it. So let's say the dog grows up and, you know, there are certain things that can change. Let's say, you know, if it's like puppies can have short hair, right? And then eventually they become long-haired dogs. Or let's say, unfortunately, you have to give the dog up for some reason and a new owner adopts it and gives it a new name. There are things that you can change and there are things you cannot. You can never change a dog's breed once it's been born. I don't think that's physically possible. I don't know. Maybe there is. What's that? Yeah, I don't even know. The hair length is probably something that can change over time, and the dog's name is definitely something that can change over time. So I want to create a few methods to basically overwrite different attributes. So let's just say the dog's name is the only thing that can change, just for simplicity. Dog name equals new dog name. At dog name is now equal to new dog name. What's that?
You need a space on line 10.
I don't need a space on line 10, actually. I'm going to move this down real quick. All right. So I have my dog. I initialize it. It's a golden retriever, long hair, and Lucky. And then I'm so proud of my dog, I'm going to print everything out. So I've got a golden retriever. It's long hair. Its name is Lucky. But unfortunately, I've fallen on hard times. I have to move across the country or something like that, and I can't take my dog with me. Unfortunately, my dog is going to get a new name. I'm going to name it Jack. I'm going to give it to Tristan. Hopefully you can take good care of my dog. So what I'm doing here on line 24 is I'm going to overwrite the attribute that I originally gave it. So I'm going to do my dog.dogName equals Jack. And that's what I have here on line number 10. I'm passing in a new dog name, and I'm going to overwrite the original. So I'm going to do this again, p mydog.dogName. Again, if this is completely going over your head, this will take a day or two to process. It's okay. So let's run this code. So we have golden retriever, long hair, and Lucky. Golden retriever, long hair, and Lucky. I overwrote the dog name over here, which is Jack, and then I printed out the new dog's name, which is now going to be Jack instead of Lucky. So I've overwritten the original attribute because this can happen every now and then. Now, this bit of code sucks. Like, I don't want to, like, again, I want to be lazy. I don't want to add additional code. Like, this kind of sucks to write. I can actually create something called adder writer dog name. So adder writer stands for attribute writer, which means that I can overwrite a certain attribute. This is also called a setter. So this is a getter, this is a setter.
So you're calling attribute reader is just if that is a what's the word I'm looking for? An ambiguous like thing?
No, this is Ruby's syntax for determining a getter.
So you always have to say attribute reader.
Adder reader. Yeah.
Adder reader.
Yeah.
Okay.
Is it me? I could have sworn when we were doing our pre-work, because we did do some of this, that there was the get and set syntax inside of Ruby. Am I wrong?
This is the get and the set.
This is it.
Yeah, this is the get and set syntax. So by having this writer here, I can actually get rid of this bit of code right in the middle. And then I can run this code again, and hopefully this gives me the exact same output as before. Again, all I did was remove that extra little bit of code. So I have golden retriever, long hair, Lucky, and Jack, the exact same thing that I expected. Again, developers are lazy. If you have something that's both a reader and a writer, so dog name is under reader and writer, I can actually make them a what, Ed? Accessor. And then I can get rid of it down over here. So an accessor is an attribute that can both be read to and written to. up to this point, we've just been doing just attributes, and that's fine. This is okay. But there are verbs that every single dog can do. Give me 3 things that every single dog can do. Bark, eat, poop. All right. Every single dog can bark, every single dog can eat, and every single dog can poop. These are things that would go on the class, like you would write it within the class, because every single instance of a dog, like every single individual. So when I say instance of a dog, that just means every individual dog. Every single individual dog can bark, eat, and poop. So I can say, I am barking. I ate all your food, that's true. And then poop, pick it up. So every single dog has the ability, so it has attributes that go inside the initialize. These are things that it knows about itself, similarly to a human. Like when you have a kid, there are properties that your kid will inevitably, that go inside of your kid. One is the name, the name, the birth date, or something like that. You know, hair color, eye color, you know, height, weight, things like that. Those last 2 can change, but your hair color and your eye color won't change, except for when you get older. Okay, your eye color will never change. So there's attributes that every single instance, every single individual dog will have. There's also methods that each one of these share. Every single instance of dog, or every single dog, can bark, eat, and poop. So what I can do here is I can actually just say, I'm going to have my dog bark, eat, and poop. So when I run this one more time, you can kind of see it prints out all of its, since I called breed, hair length, and dog name, breed, hair length, and dog name, and then I can also tell it to bark, eat, and poop. I'm barking, I ate all your food, and pick it up. So this is like just a very easy example. I'm going to just kind of leave it right. Oh, I'm gonna do one more thing. Let's say a dog can talk for a second. Just, you know, introduce yourself. Let's pretend for a second that dogs can talk, and the dog can introduce itself. At this point, I want to use all of the instance variables that once existed here. Maybe I'll just call it, I'll just do output equals a string. I'll have an output at the very bottom. Output plus equals, hello, my name is dog name. I am a breed. Pardon?
Output. Puts P or return.
Puts P or return.
Output
Output's just so I'm showing examples of local and external, local and instance variables. Real quick. I might answer your question right now, but in case I don't, ask it again. So inside of introduce yourself, I'm going to get rid of all of this. I don't care about all of this. I'm just going to do p my dog dot introduce yourself. So again, I created a new instance of my dog. It's a golden retriever with long hair named Lucky. This particular instance, I'm telling it to introduce itself. Every single dog, let's pretend, can talk and it can introduce itself. So I've created local variables. This local variable called output only exists within lines 11 through 19. The instance variables live anywhere between lines 1 and 32. It's accessible everywhere for this particular dog. So I created an empty string. I've added to it, says, hello, my name is dog name. Dog name, because it's an attribute accessor, I'm reading the instance variable over here. So I can either have dog name as a method, or I can have @dog name as an instance variable. It's up to you. But since you have it as an adder accessor and adder reader, you can just call it as a method, which will read the instance variable. I'm a breed, and my hair length is whatever. Is there a baby in there? Ruby object orientation. Hello, my name is Lucky. I am a golden retriever. My hair length is long hair. There is a baby in this office. Okay. So this is, I just kind of want to demonstrate this output cannot be used anywhere else except for lines 11 through 19. If I call it over here and I do bark, it'll blow up. So I'm going to say introduce yourself, and I'm going to do pmydog.bark. Run it one more time. It blows up right here. There's an undefined local variable or method output here on bark. Sean?
Is everything scoped to the block inside of Ruby? Is there no lexical scoping?
That's the so yes, local variables are scoped within this particular block, and then the instance variable is scoped within the class. All right, any other questions? So we're going to be using object orientation today to tackle a few challenges for today and for this weekend. As we move forward, everything is going to be more or less object orientation so that you can effectively speak during an interview what are OO principles and things like that. So let's take a look at what we've got today, and then we'll take a break for about 15 minutes or so, and then we'll do our retro. So I have a couple we'll just say pairing challenges for today. Credit check is always fun. So credit check is it's called the Loon algorithm. It's basically when you swipe your credit card, or when you give your credit card information online, how do they know that it's actual credit card? There's an actual algorithm behind it, so you're going to write that. And then we're going to do stuff inside of Boggle. So Boggle, we're going to be using object orientation to basically print out a Boggle board using OOP. And then optional, Boggle part 2, it's pretty difficult. And your only homework for today is to finish Boggle 1 and 2. There's also some weekend homework. This is very simple. Find the mode, do a guessing game, and pad an array. These should take, an hour at most for all of them. Sean? No? Okay.
So object-oriented programming and JavaScript is
more or less the same thing. So if I were to do the same thing, so the question was, what does object orientation look like inside of JavaScript? I can't say for certain for all JavaScript, but I know the React version of JavaScript. Let me just change this to JavaScript. I think it's class dog, and then constructor, and like this dot, and this would take in like a bunch of props, like properties. And then this dot breed equals props dot breed or something pretty similar. So the this is equal to the @ symbol. Yeah.
It's just this dot breed equals props.
Is that functioning also as the getter and setter, or is that just the initialize?
Yeah, you actually have get and set.
Yeah, you can get and set everything in here, but it's fairly similar.
Okay.
Once we get to React in 2 months. And when we start doing stuff inside of object orientation, I'll tell you exactly everything that's meant to be changed. Right now, I just want you to focus on Ruby's version because it might be too much to do both.
Okay.
So, yeah.
Okay.
It's very, very similar. The constructor is equal to the initialize. It takes in certain properties just like this, and you can just do this dot breed instead of @breed. It's just like very, very small implementation details. The concepts are the same.
And like the syntactic sugar now is so.
Yeah, but many languages are just very, very similar. Inside of Python, it's almost identical as well. So let me stop recording here, and then we'll take a break. 10 minutes, 10:45. We'll be back.
A couple of things.